Assalamu alaikum wa rahmatullahi wa barakatuh. Today I will be explaining the chapter 2D force system equilibrium. Equilibrium it means all resistance force equals zero. We have two most important things in this chapter. The first one, draw the free body diagram. The second one, write the three equations equal zero. Sigma fx equals zero, sigma fy equals zero, sigma of moment equals zero. In this slide we can see the different type of the supports. We have the roller supports. All this, the roller supports with the different shape, it's contain only one force. And this, in the second one is we will have the pin supports. It's equal to two forces act on it. Also we have the fixed supports. It's contain two forces plus the moment. The weight is equal M multiply G. In this slide we can see the free body diagram. It should be easy and clear. In the first one we will have the P forces here, and we will write in the free body diagram in the same directions. Here we will have the P, the roller supported, so it's contain only one force. And here we will have the pin support, it's contain two forces. And we have the M. When we multiply the G, we will define the weight. And the second one we will have the box, it's contain the mass. We will when we multiply in G, we'll define the weight. And here we have the tensions, and we will have here the pin support, it's contain two forces. Now we have the small example of the beam. We have the pin support and the roller support. We will write the free body diagram. In the free body diagram, the pin support, it's contain two forces, AY plus AX. And also we have the down 4 kilonewton in the vertical line, and we have the PY before the pin support, the roller support. We will write the three equation equal zero, and we have the AX equal zero because it's also the one force in the X directions. And we will write E sigma Fy equals zero, AY in the up direction, BY plus BY minus 4 equals 0. We have two unknowns, so we cannot define any solution. So we will take the moment in the A. We choose the A because the A is cancel more forces. We have BY and the D distance 4 plus 6 and minus 4 kilonewton multiplied by the 6, it's equal 0. Now we find the BY, so we can find AY. In this example, determine the magnitude of tension in the supporting cable and the magnitude of the force on the beam at A. It's the point A. For the G beam show that the beam AB is a standard 0.5 meter with the mass 95 kilogram per meter of the length. The mass it should be kilogram, not kilogram per meter. So we multiply the 95 kilogram per meter for the length of the beam. The length of the beam is 5, and multiply in the G to determine the weight. This is the weight. Also the weight, it should be in the middle of the beam. We have here the A point, it's not in the end of the beam, it's nearly the distance between the end is 0.12, and we will have the moment because it's the fixed support, and here we will have the tensions and the angle with the cosine with the x-axis.
Now we will define the weight. The weight is equal m multiply g. We have the 95 kilogram per meter. So when we play the 5, the length of all the beam, we convert the kilogram, and the g is 9.8, and the resultant division by 1000 we get the kilo, and we have 4.66 kilonewton. Why we'll convert the kilo? Because here all the forces, it's the kilonewton. Now we will take the moment, the sigma of moment equals 0. We will choose the point A. We have the T tension and cosine 25, and the distance it is here, the distance, because this is the x-axis. The distance is 0.25 plus we have plus the t sine 25. The distance, it's equal 5 minus this distance. This distance, it's 2.12, and minus 10. The distance 3.5 minus 0.12, and minus 4.66. The distance is 0.12 equals 0. Now we will sum of this, because all of the tensions, and we will take this and this opposite directions, and we will define all side by 2.29 to determine the tensions. Also the unit, it's kilonewton. Now we will write sigma of x equals 0. We have ax minus t cosine 25. The ax is equal 17 plus 77 kilonewton. Then we will write the sigma of y equals 0, and we have ay minus 4.66 minus 10 kilonewton plus t, because the t is up direction, the y-axis, ty sine 25 equals 0. We define the ay. Now we can define the magnitude. The magnitude is the square root and ax square plus ay square. We have here the magnitude 18.88 kilonewton. The reference is Static Engineering Mechanical book. Thank you for listening.